We're going to start with 1.3 complex numbers. And what I would like to do first is to explain all the number systems so we have a good start for the semester. So we started with what we call natural numbers, and the natural numbers are also sometimes called counting numbers, and the reason is, as you can see, they are the counting numbers 1, 2, 3, 4, 5 and so forth. Then the design is very important. Then if we put a bigger rectangle around that and add the number 0, and when we put something around it, meaning this set is included in this set. So if we add 0 to the 1, 2, 3, 4, 5, then we have what we call a whole number. Then if we add another rectangle or square and put negative, but they're still whole numbers, but add the negative, so I have the negatives, whole numbers, the 0 and the positive, we call those integers. The minute we add fractions, but not any fractions, so a number over a number, meaning an integer over an integer, no matter how it is, then we get what we call rational numbers. What is nice about rational numbers, and nice to know, that something like a 1/2 is a natural number. If you, for example, put this in the calculator, you're going to get 0.5. And in this case, the decimal terminates. If you put something like a 1/3, which is also a rational number, put that in the calculator, you're going to see that this is a 0.33333 repeated. So what's nice about rational numbers, or their quality, or their the definition of it, is that the decimal either terminates or repeats endlessly. Now, as you can see, we're gonna stop for a minute. We're not gonna add more here, but on the side, we're gonna add something. We're gonna call them irrational numbers. These irrational numbers are opposite of rational, meaning the decimal of it. So I entered the square root. Let me show you actually. Let's enter, for example, the square root of 2. And you will see that the decimal does not repeat and it does not terminate. It's going to go on and on. Of course, this computer, we told it to stop at so many decimal. But if we don't, then you're going to see it going forever. So these are irrational numbers. Square root of 2, square root of 15, pi, that you know. We're going to study in this semester here the number e, lowercase e. All these are irrational numbers. Now, if we put a big circle around this here, this is what we call real numbers. So the minute we say a real number, then we know that it could be any of these. Even irrational, it's a real number. It's ugly, but it's a real number. Then we turn to this lesson, and you're going to read it, and we introduce the imaginary unit, which is the lowercase. Let us just to show you a little bit here. You're going to read it, of course, and look at the videos, but we have I, the lowercase I, which is square root of -1. That's imaginary unit, and from it we introduce the complex numbers. And we have pure imaginary. Complex numbers, our numbers can be written as a plus bi. Okay, where a and b are real numbers. Again, you're going to have a pure imaginary numbers that do not have the a. It's just 3i, -i, 5i, 7i. All these called pure or non-real complex number. And these are a plus bi. So 5 plus 2i, stuff like that. 2 plus 3i. Now, what's so weird about all this is that if you put all these together, this is the whole thing. Even the real numbers are what called complex numbers. Again, so complex numbers, a plus bi, where a and b are real numbers. So the real numbers are actually complex number, but they're special case. B is 0. So when B is 0, you're going to get only A, which is a real number. Okay, so that I just wanted to clear that out, but you can, of course, see it and read it and do all that. I'm going to just do a few examples with you here. And again, you have a lot of videos. These are extra. So, and these notes are available for you in the My Math Lab. So now we are going to look at this. How do we simplify the square root of negative 63 over the square root of 21? The idea is that if I have a square root of a negative number, that's immediately an I. So you take the I out, and I'm left with the square root of 63 over the square root of 21. But wait a minute. When we have two square roots, we can put these two square roots under one big happy square root. You get 63 over 21. And if you divide 63 over 21, you're going to get 3. So what we end up with is I root 3. Now, it's the same as square root of 3i, but it's a common practice to put the I before the root because we are worried that we're going to extend the root and it will look wrong. Let's look at how we can write things in standard form. Again, you have a few examples worked out for you. You have a video, but let us do some together. So how can we write this in a standard form? The standard form is what? A plus BI, okay? So here it is. The first thing is, why don't we separate the fraction? So it's negative 12 over 24 plus the square root of negative, so I have an I, the square root of 45 over 24. And now all we need is to simplify. Negative 12 over 24 divided by 1, it's negative 1/2 plus. Now 45 is 9 times 5. The 9 comes out as 3, so we have a 3i square root of 5 divided by 24. We'll see that we're not done. In math, you have to simplify all the way. So now we'll see that what we have is negative 1/2 plus the 3 goes into 24 8 times. So what we have is I root 5 over 8. Okay, let's do another one. This one, separate again, negative 6 over 2 plus I see it already, square root of 24 over 2. Divide, you're going to get negative 3 plus I. 24 is 4 times 6, and the 4 comes out as 2. And what's left inside is 6. 6 times 4 is 24, and now the 2 goes with the 2, and we end up with negative 3 plus I square root of 6, or square root of 6i. So that's how we simplify. And those will be in your first part of 1.3.